Okay, so the whole point of this section, these three sections, and I don't know, ML Math does some kind of job with it, and they're okay. I mean, it's nice automated practice. But really, what I want you to do, and the textbook has a lot of different tricks. So you read about Descartes' rule of signs, you deal about all the bounds tests, there's other kinds of tests we can do, and those are all pre-calculus ideas, and pre-calculus being before 1700. Now, I'm recording this in early 2023, and we have other tools available. And what we're trying to do is, well, really what I need you to know is that the fundamental theorem of algebra tells us you take a look at the biggest degree in a polynomial, and that's how many solutions there are. Doesn't mean they're all real solutions, but that's how many solutions there are. So I created this function so it would have 4 real solutions. I'll do one with 2 complex solutions in the next part. But so then what I did, and this is what I encourage you to do, is to find all zeros for this polynomial function. So I graphed it with Desmos. Please graph it. We don't have to do all those other things. And then what you look for is for the integer solutions. So in this case, I see, and actually I see 4 real solutions. So I know that's true. Maybe I said that already. But the ones that are integers, the ones that I know I can factor out, and then I can use some analytical techniques to find the decimal values. And that's what I want you to be able to do is to graph it, find the real values, remove those from the mix, and then deal with the ones that's left over. So I see x equals 5 as a solution, negative 5 as a solution. So I'm going to take this polynomial and I'm going to apply synthetic division to it. Now you probably got that practice where you just take the coefficients off each term and you write them down and you put the thing you're dividing by on the outside here, right? Outside here. And then what we're going to do is, and I always do this as a placeholder to get myself started, you bring down that leading coefficient and then you multiply. 1 times negative 5 is negative 5. Write down, we add negative 1. So negative 1 times negative 5 is positive 5. And then negative 25 plus 5 is negative 20. Then we're going to multiply negative 20 times negative 5. We get 100. And that's going to be 20. And 20 times negative 5 is negative 100. And we get a remainder of 0. We knew there was going to be a remainder of 0 because the y value was 0. And remember that the synthetic division is the same as synthetic substitution. That's telling me f of negative 5 for that function is 0 because it's a 0. So now we also see we've got an integer solution of positive 1. So with what remains here, we're going to run synthetic division through that. Bring down the 1, we get 1, we get 0, we get 0, we get negative 20. We multiply, we get negative 20, we get 0. Again, that's a factor. So what I was able to do is I was able to factor out a 5, a negative 5, and I was able to factor out a 1. And what I have left is, now this was a 4th degree equation, I just divided off of x to the power 1 twice. So this 1 that's right here is represented by x squared minus 20, because there's no x term. Now to find when x squared minus 20 equals 0, well, we could use quadratic formula, but I'm going to suggest to you, since this is just a binomial, we could actually just extract the square roots here. Set it equal to 0, move the 20 over, take the square root. Well, the square root of 20 is the same as, 4 times 5. And the square root of 4 and the square root of 5 is what we do. So I'm going to get x equals 2 square roots of 5. And actually we get plus or minus 2 square roots of 5. And if I would dare say, unless I screwed up, of course, that if you were to punch those in your calculator, you would get negative 4.47 and positive 4.47. So that's how we use Desmos and synthetic division to find all the zeros. Exactly, we look for the integer values, and that's what that bounds test would help you do, but we don't have to do that. Let's try another problem. Okay, so for this polynomial, I see a fourth degree equation. I know I see the ending behavior looks like this, as we expect fourth degree polynomials to be. So I know this can't curl around, back around, so I see only these two real zeros at -4 and at +3. So there must be, the fundamental theorem of algebra says there's supposed to be four solutions. So there must be two of them are complex. So this is what we need to deal with in order to find those. So I'm going to remove these two real zeros from the mix by running them through the equation with synthetic division. And hopefully you know how to do that. And then we're going to drop in 1, drop 1, that's -4, which gives me 0, and 0 times -4 is 0, and that's -27, and -27 times -4 is +108. So what that leaves me with is that leaves me let's not go there yet. Anyway, so now I see another real zero, +3, and I'm going to run that through. Bring down the 1. I get 3. I multiply, I get it 27, and that's 27. No, I get 9, don't I? Oh, yes, that's what I get. Yep. That's 9. That gives me -18. Okay, so what I've got for factors is I've got x plus 4, I've got x minus 3, and then I've got this x squared plus 3x minus 18. And that's because, remember, if we divided by an x squared, if we took x to the 4th, divided by x, that leaves x cubed. We divided that by another x, and that left x squared. That's why we ended up with x squared. So we've got to figure out how to get the zeros from that x squared minus or plus 3x minus 18. So what we're doing is we're saying x squared plus 3x plus 18. Where does that equal to 0? We see this is a second degree equation. That means it's a quadratic equation. So that means you can use the quadratic formula, which is negative. And remember, in this problem, a is 1, b equals 3, c equals 18. So it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now we got some arithmetic to do. And order of operations says do things in exponents first, and a radical's an exponent. So -3 plus or minus the square root of 9. And let's see, 4 times 18 is going to be -72, isn't it? All over 2. And 9 minus 72, I think, is 63. -3 plus or minus the square root of a -63 all over 2. And then we can clean that up a little more. We know the negative is an I, so we're going to do 9 times 7 times -1. So those all have the square roots. So I'm left with -2 plus or minus. Now the square root of 9 is 3. We need the I from the negative, square root of -1, and the root 7 is coming along for the ride, and that's all over 2. So we've got two zeros there. It's a second degree equation. There should be two zeros. So the first zero is x equals -2 minus 3i root 7 all over 2. And the other one is x equals -2 plus 3i root 7 all over 2. So we've got -4 is a 0, we've got +3 is a 0, and then these two zeros, and that's a total of 4. And that's all you need to worry about.